Got a couple of problems someone asked me to do. This is 10-5. Numbers 5 and 7. These are problems from the online part, from WebAssign. These correspond with numbers 27 and 35 in the book. So for the first one, we have r equals 1 plus cosine theta, r equals 1 minus sine theta, where 0 is less than or equal to theta less than 2 pi. And we're supposed to find the points of intersection. And if you look at the graph of this, I'll try to do a decent job recreating the graph. You have ones like this. And then one that is lemicon on its side. So pretty rough there. And we see a couple of things of intersection. Maybe I should do that with a separate color. Change my color so we can really see what's happening. So, okay. Points of intersection. We have a point here of intersection. We have a point here of intersection. And we have a point down here of intersection. So we want to find these points of intersection. So if we set them equal to each other, we have 1 plus cosine theta equals 1 minus sine theta. And we can subtract 1 from each side, so that cosine theta equals negative sine theta. If I divide both sides by cosine theta, then 1 equals negative tangent theta, or tangent theta equals negative 1. So that theta would be arctangent of negative 1. I think we know what this would be. This occurs two places whenever theta is going to be 3 pi over 4 and 7 pi over 4. You know, here and down there. You get a negative 1. I did 7 pi over 4 because we're talking being between 0 and 2 pi instead of doing negative pi over 4. Okay. So that's the first part. But there's something else. We see 3 points of intersection. I guess I should go on. The book tells us, I forget what page it is, that we should replace r with negative r and theta and theta with theta plus pi in the first equation. So then we'd have negative r equals one plus cosine of theta plus pi. So negative r equals 1 plus, and if we break that down, that's going to be cosine theta times cosine pi minus sine theta sine pi. So negative r equals 1 plus, and that would be cosine of theta times negative 1 minus 0, because sine of pi is 0. So negative r equals 1 minus cosine of theta. Or divide both sides by negative 1, r equals negative 1 plus cosine theta. And if we set this equal to the sine part, negative 1 plus cosine theta is going to be equal to 1 minus sine theta. And I can add 1 to both sides and add sine to both sides. And we have sine theta plus cosine theta equals 2. Now, there are places that sine and cosine could be equal, but there's never going to be a place that sine is 1 and cosine is 1. If we remember that sine has a maximum value of 1 and cosine has a maximum value of 1, then this can never occur. There's never going to be a place that the two of these added together is going to be 2. So there's no solution from this. So that will not yield any more values. But something I do want to point out, go back up here, we do see this occurring. And we know that both graphs go through the pole at different times. So r equals 1 plus cosine theta. This goes through 0, 0. Well, this goes through r equals 0 whenever what happens? Whenever theta is pi. So 0 pi. R equals 1 minus sine theta. Now r is 0 for this, 1 minus sine theta. Whenever 1 equals sine theta. So theta would be pi over 2. So it'll go through 0 comma pi over 2. But we know by observation it goes through there but not at the same time. So it'll go through the pole. They're both going through this pole here but not at the same time. So we have the other points. Theta is pi over 3 pi over 4. And theta is going to be 7 pi over 4. And then we know that the point when it goes through there is at 0, 0. Where r is 0, theta is 0. That's going through that location. So let's go ahead and say, okay, r equals 1 plus cosine theta. For theta being 3 pi over 4, r equals 1 plus cosine 3 pi over 4. Which is going to be 1 minus square root of 2 over 2, which would end up being 2 minus the square root of 2 over 2. And the other one, r equals 1 plus cosine theta, for theta being 7 pi over 4. That's going to be r equals 1 plus cosine of 7 pi over 4. So r equals 1 plus the square root of 2 over 2, which is 2 plus the square root of 2 all over 2. So our points are going to be 3 pi over 4, comma, 2 minus the square root of 2 all over 2, and 7 pi over 4, comma, 2 plus the square root of 2 over 2, and at 0, 0. And that's by inspection, not by calculation. The first two are by calculation. And I did plug in the first equation. You could plug in either equation, but they are coincident there. Okay, now I'm trying to record this screen. I hope it's recording it. So here's number 7. It starts off by asking us to graph r equals 2 plus 5 cosine theta and r equals secant theta over 2. So I have them in the calculator, and my window, you might be interested to see how I have that set. The problem says go from negative pi to pi, so I've done that. My step is basically, I think it's a pi over 12. And then I do the x min negative 8 to 8 max for x max, and the y min is negative 6 to y max is 6. And I go to graph this, and I have it redraw it for you. So it's drawn that first one. The second one is a vertical line, and that vertical line should come all the way down, but it doesn't. So that's what the graph looks like. So if you're looking at the choices, that looks different than what the book. Oh, okay. The book says the answer, I think, is B. So that is the correct one. Okay, so now it asks us also to approximate the points of intersection of the graph, confirm your results analytically. And so I'll do this analytically now. So let me close off this graphing program. Okay, so we have r equals 2 plus 5 cosine theta, and r equals secant theta over 2. So we're going to set these equal to each other, and 2 plus 5 cosine theta equals secant of theta over 2. So I'll multiply both sides by 2, and I have 4 plus 10 cosine theta equals secant theta. And we'd have 4 plus 10 cosine theta equals 1 over cosine theta. I'll multiply both sides by cosine theta. And I have 4 cosine theta plus 10 cosine squared theta equals 1. So it's starting to look like a quadratic. And if I subtract the 1 and rearrange the order, I'd have 10 cosine squared theta plus 4 cosine theta minus 1 equals 0. Now, if we say u equals cosine theta, what we have is 10u squared plus 4u minus 1 is 0. So u would be negative 4 plus or minus the square root of 4 squared minus 4 times a is 10 times c is negative 1 all over 2 times a is 10. And I just use the quadratic formula there. So u is negative 4 plus or minus square root of 56. I'll skip that step. I'll let you do the arithmetic there. So u would equal 0.1742 or negative 0.5742. We're not finished yet. We still have a ways to go. So cosine of theta would be 0.1742. So theta would be cosine inverse of 0.1742. And theta would be, remember it said negative pi to pi. So we're looking at values in this range, negative pi to pi. So theta would be 1.3957 or negative 1.3957. And likewise, cosine of theta would be negative 0.5742. So theta would be cosine inverse of negative 0.5742, meaning theta would be 2.18238 and negative 2.18238. But we're still not done. So we have the case, we have 1, 2, 3, 4 values. So pick one of the equations. R equals, what was it, 2 plus 5 cosine theta, and plug these points in. So R equals 2 plus 5 cosine of 1.3957, and that's going to give us 2.871. So that point would be 2.871 comma 1.3957. R equals 2 plus 5 cosine of negative 1.3957, which would become, again, 2.871. And then we have R equals 2 plus 5 cosine of 2.18238. And that's going to be negative 0.8708. and r equals 2 plus 5 cosine of negative 2.1238. That'll also be, any guesses here? Yep, negative 0.8708. So negative 0.8708, 2.1238. Those are the points of intersection. Hope that makes sense.